This is a screencast on how to describe the purpose and parts of a histogram. Now, in front of you have two graphs. The one on the left, this one here, is a histogram, while this one over here is a bar graph. Now, one of the things that people commonly do is they mix these two up. Now this graph here is showing a massive fish, while this one over here is showing the favourite type of movie. Now they look very similar. They both got bars going up, they both got frequencies, they both got titles, all those things, but there's a big difference. There's two differences. Number one is that you'll notice on this firstly is that here the bars, there's no gap between the bars. Well, over here there's a gap. Now that's an important feature that relates to the next difference. The difference is also is that down here along the x-axis, these are categories. This is comedy, action, drama, sci-fi. Well, over here the category is between 10 and 12. So that can include number 11, 12 to 13, 14 to 16, 16 to 18, so right, it covers a range of numbers. When you have something like this, it's called continuous data. So it's continuous because it covers 10, 11, 12, not just the number 10. Well, over here this is what is called discrete, or it's a category. So in this one here, it's comedy. So only comedy can be in this thing, in this column here. So here's why that they're joined together. These are separate because they're categories, while this along here is continuous. So it's an important distinction to remember. Anyway, let's look at an example of the features of a histogram. So here is a histogram. I'm sorry I did not have that large when I first. So we've got the same one, the masses of fish. Now there's a number of features we can point out. Number one, like all graphs, this has a title. Title clearly explains what the graph is about. Along here we have what is called the y-axis. The y-axis indicates the number, or in this case the frequency, and the axes will always be labelled, and so you can quite clearly see these are measured out in intervals 5, 10, 15. Along the bottom here you have what is called the x-axis. Now, as we described before, it is for continuous data, and continuous again means between 10 and 11, 12 and 13, 14 and 15, 16 and 18. And the reason it's continuous because there's lots of numbers between there, as there is between here. It's not just one category. And again you'll see that it's been labelled down here, mass in kg. So now we know that, we can simply, so you can see the main features, as you can see at the moment, are the title, the y-axis with its label, the x-axis because it's continuous data with its label. Now once we know that information, we can actually read and apply this graph. So for instance here, if I was to ask you how many fish were caught that were between 14 and 16 kg. So the first thing we would need to do is go to the graph down here, the 14 to 16 part, read up to the top of the bar here, and then read across, and as you can see, it's not at 15, but it's not at 10. So if I go 10, this makes 11, 12, 13, so 13 fish were between 14 and 16. Try another one, which was the lowest mass caught. And as you can quickly see on this graph, it is 10 to 12 because their bar is lower. Let's try another example. Again, similar features as the last one. You again have a title, very clearly stated, results of the mass test. You then have the y-axis here with its label, in this case frequency, which means the number of times it happened, and then you have the x-axis down here with its continuous data from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and then mark out a 50. So, let's have a look at reading these results. So if I was to quickly ask you how many students scored between 10 and 20, you can go straight to the x-axis. There's 10 and 20, move up, here it is, move across, and you can quickly see when we look on the y-axis that matches up to 2. So 2 students scored that. Which one had the most amount of students? What score was the most common? It's between 30 and 40, because this has the tallest part of the graph. Let's look at the next one. This one here, you have a number of, again, has title, label down the sides. This time it's 0, 2, 3, 2, 4, 6, 8, 10. It's got the frequency, x-axis along here, it's the height in feet. And against it's continuous between 60 and 70, 60 and 65, 65 and 70, and so on. So if I was to ask you what was the total amount of trees measured, slightly different question. It's actually quite easy to do. All we need to do is go, there are 3 in this one, 3 here, 8 here, 10 here, 5 here, and 2 here. And all I did to get those was to look at where the bar got up to on the x-axis, and these are halfway between. So then I just add those up. So 3 and 3 makes 6, plus another 8 makes 14, plus 10 makes 24, plus 5 makes 29, plus 2 makes 31. So 31 trees were in fact measured.